Solving system of linear equations solved by addition or elimination method. Welcome to Mark's Math Methods. The key to the addition-elimination method for solving a system of linear equations is, anybody know? Additive inverses or opposites. Well, that's because 3x plus negative 3x is 0, and those are additive inverses or opposites. And you can also multiply an entire equation by a common factor. So these are the two pieces of theory we'll need for this. Okay. Opposites cancel each other out, and we can alter an entire equation as we multiply every piece, both sides, by the same thing. There are 5 steps to solving a system of linear equations using the addition or elimination method. So here's the system. Step 1, look for additive inverses. Look for opposites. Well, look at that. The negative 3y and the positive 3y were already opposites. So the first step is done. Step 2, multiply one or both equations by a number to create opposites. Not needed in this case because I already got opposites. Step 3, add the equations and then solve for the remaining variable. So if I add the two equations together, 2x plus 5x is 7x. The y's cancel. 18 plus 3 is 21. So I end up with 7x equals 21. And I solve for x and I get 3. Step 4, back substitute. Oh, that sounds familiar, doesn't it? Back substitute into the original equation to find the second variable. So I'm going to use the top equation, and I'm going to put an x, a value of 3 in there, and solve for y. And I get y is negative 4. So I think the answer is 3 comma negative 4. 3 for the x, negative 4 for the y. In step 5, check both in the other original equation. Since I used the top one to find my second variable, 2x minus 3y equals 18, I need to use the bottom equation, 5x plus 3y equals 3, in order to find my second variable, or to check them. So I plug a 3 in for the x, negative 4 in for the y, and I get a true statement. So the answer is 3 comma negative 4. If you remember from substitution method, the only thing that really changed are steps 1, 2, and 3. Steps 4 and 5 are the same. It's how we get our first variable. That's the only difference between the two methods, is how we get our first variable. It's called the addition method because we're adding the two equations together. It's also called the elimination method because in this case, we're eliminating the y. Let's try another system. X plus 3y equals negative 11, and 2x minus 4y equals 8. Step 1, do you remember? Look for additive inverses, opposites. Well, there aren't any. X and 2x are not opposites. 3y and negative 4y are not opposites. So I don't have any. Step 2, multiply one or both equations to create opposites. So I have a choice. I can make the x's opposites or I can make the y opposites. It doesn't matter which one you choose, whichever one's easier for you. I could make the x's opposites by raising the top one up to a 2, and then I'd have to make it negative. So I'd have to multiply the top equation by -2. Or I could bring the y's up to 12s, multiply the top equation by 4, the bottom equation by 3. They're already got opposite signs, so I don't have to worry about inserting a negative. I choose the x's because I only have to alter one equation. Okay, I only have to alter one of the two equations. That's why I choose the x's. You can choose the y's if you want, but I'm going to choose the x's. So I'm going to multiply the top equation by -2. That's going to give me a -2x minus 6y equals 22. I'll slide the other equation back over, and you can see I've got opposites. Step 3, add the equations and solve for the remaining variable. So it looks like y is -3. The x's cancel. -6y, -4y give me -10y. 22 and 8 give me 30. Divided by -10, I get -3. Step 4, back substitute into one of the original equations. I'm going to choose the top one. Notice I didn't choose -2x minus 6y equals 22, the one I created. I chose the original, x plus 3y equals -11. Plugging in the y value of -3 gives me an x value of -2. So it looks like the answer is -2, -3. Step 5, check both in the other original. And it checks. So now we know the answer is -2, -3. So in this case, I only had to alter one equation. Let's try this system. I don't have any opposites. 3x and -4x are not opposites. 2y and 3y are not opposites, so they don't cancel. So I need to create opposites. The x's, the least common multiple is 12. The y's, the least common multiple is 6, looking at their coefficients. So I can either make the x's go away, or I can make the y's go away. Normally we would go for the smaller number just because it makes the math easier. But in this case, since the x's already have different signs, I don't have to insert a negative to multiply. So I multiply the top equation by 4 and the bottom equation by 3 to create my opposites in the x's. So I had a choice. I chose to multiply to get rid of the x's only because I didn't have to make one of the numbers I multiplied a negative. Because people always tend to forget to carry it into the last number at the end. Okay? And we add them together and solve for the remaining variable, so we think y is 2. Step 4, back substitute into an original equation. I'm going to choose the top one again, and I get x is 1. Plugging a 2 in for the y gives me an x of 1. So I think the answer is 1, 2, but I'm not sure. I need to check it, because I could have made a mistake. So let's check it. And it does check. I plug 1 in for the X, 2 in for the Y, and it checks. So the only difference between substitution and elimination or addition method is how you find the first variable. Once you find the first variable, it's the same thing. Back substitute into the original equation, solve for the other variable, and then check them both in the other original. Again, for this method, we're looking for opposites. They may be given, as in the first example. I may have to multiply only one equation, as in the second example. In this equation, I had to multiply both equations. So here's another one. Might need to rearrange. In this case, I need to rearrange that top equation so that my x's, y's, equal sign, and constant all line up. So I moved the negative 2x from the right to the left where it became a positive 2x. Now, I'm not given any opposites, so I'm going to turn the x's into 6's. So I'm going to multiply the top equation by negative 3. And opposites. Uh-oh. I got another set of opposites. Okay. So sometimes this happens. When we add them together, the variable disappears and we get a false statement. So this is very similar to what we experienced in substitution method. A false statement. Variable disappears, false statement. False statement means no solution. Okay? Oh, drats, I got fractions. We don't like fractions. Let's clear those fractions first. So I'm going to multiply by 6 to get rid of those fractions. Oh, whoa. That's interesting. So I'm not given any opposites, but I can make them easily by multiplying one of the equations. I'm going to choose the bottom one by negative 1, which now gives me opposites. And just like before, everything canceled. But in this case, I got a true statement. And if you remember from substitution method, if the variable disappears and you get a true statement, it means there's an infinite number of solutions. So this is how you write the answer. The set of all x, y's such that, and then you pick one of the two equations, one of the original two equations. I'm going to choose the one without fractions just because it's easier to write. I hope the presentation was helpful. Thumbs up, subscribe, comment. And if you have any problem types you'd like me to demonstrate, there's my address.